Is our sun going to die? And if so, when and how? Stars are energy sources powered by nuclear fusion. Our sun, for instance, is a giant nuclear reactor that consumes about 600 million tons of hydrogen per second. This begins with two protons in a high-energy collision that results in the synthesis of a new nuclear species, deuterium, together with the emission of secondary particles, a positron and a neutrino, plus energy. Such nuclear processes take place under highly unfavorable energy conditions thanks to a surprising microscopic effect known as quantum tunneling. In fact, the sun would not shine without quantum physics. The sun is a nearly perfect sphere of hot plasma with a mass of about 10 to the 30 kilograms. Most of this plasma is in the form of ionized hydrogen, that is, protons. Therefore, the sun can be considered as a giant sphere made out of protons, a huge amount of protons. How many? A simple estimate can be obtained from the ratio of the mass of the sun over the mass of one proton. Certainly, a huge number. To this end, we'll rely on a number of back-of-an-envelope calculations. In just 1 second, the sun releases 10 to the 26 joules of energy. For comparison, a single roasted and salted peanut contains an energy of 25,000 joules from a nutritional viewpoint. Therefore, the energy emitted by the sun per second is comparable to the energy contained in, say, 4 sextillions of peanuts, that is, 4 times 10 to the 21 peanuts. Such amount of peanuts would fill 10 billion football stadiums like the Camp Nou in Barcelona. In fact, the cost of such amount of peanuts would certainly not be peanuts. In the nuclear processes that operate in the center of the sun, 4 protons are effectively invested, consumed, fused to form a single helium nucleus. With a total number of 10 to the 57 protons, the sun can potentially undergo a total number of 10 to the 57 divided by 4 hydrogen fusion reactions in its entire life. Each of these reactions produces 10 to the minus 12 joules of energy. We can actually take this number to estimate the overall energy production through nuclear fusion reactions in the sun through its entire life, as shown here. Now, the time required by the sun to emit 10 to the 44 joules at the current rate of 10 to the 26 joules per second will be 10 to the 18 seconds, that is, 10 billion years. This is the expected duration of the sun, 10 billion years, a number that agrees fairly well with the value obtained through more complex calculations. Radioactive dating of solar system samples have revealed that the age of the sun is about 4.6 billion years. Therefore, the sun is halfway through its entire lifespan. So, is our sun going to die? Certainly yes, but only after 5 billion years from now, when most of the hydrogen of its central layers, its nuclear fuel, would be consumed. In the meantime, let's benefit from the remaining billions of years to expand our scientific knowledge. For instance, how do we measure the nuclear processes that occur inside the sun and other stars? These and other questions will be addressed in the next video of Astronuclear Nibbles.